So if you work with the data, you definitely know the feeling we're talking about
Oh,
today.
totally. The dread.
Right. You're staring at this massive data set. Maybe it's loaded with sensitive customer financials or, protected health info. And you have to run some complex
And the
aggregations.
standard operating procedure for, like, the last decade has just been to drag that file into a browser window, right?
Exactly. You hit upload and just sit there watching that progress bar inch across the screen. You're effectively handing your most sensitive intelligence over to some remote server farm.
Yeah, just crossing your fingers and hoping nobody's snooping around on the back end.
We just accept it. We accept the latency, the crazy cloud storage fees, and the security vulnerabilities. Like, it's just the unavoidable cost of doing business.
Well, we've been completely conditioned to believe that heavy analytical computing actually requires a massive centralized cloud infrastructure.
Right.
I mean, the industry traded absolute privacy and local control for the convenience of web-based dashboards a long, long time ago.
But today, we are tearing that assumption down. So, welcome to today's deep dive. We are unpacking a platform called Datok.
It's a fascinating tool.
It really is. And our mission today is to explore how this tool executes high-performance data processing without ever sending a single byte of your data to the cloud.
Which sounds impossible, but it works.
Right. We're going to examine the physical realities of local memory limits, how this architecture forces analysts to, become better data engineers, and how you can share these highly interactive dashboards securely.
And to do this, we're synthesizing a really thick stack of Datok's technical user manuals, their system architecture docs, and a series of interface blueprints.
Yeah, that documentation gives us a super clear picture of how the engine actually routes data under the hood. So if you're listening to this and you've ever felt that knot in your stomach while uploading proprietary files to a third-party server,
Or if you're just exhausted by web apps that take 10 seconds to render a basic scatter plot.
yes. This deep dive is going to challenge how you think about software. We're looking at a paradigm shift where your own local machine reclaims all the heavy lifting.
Which aggressively pushes back against the whole cloud everything trend.
Exactly. Let's jump right into Datok's core philosophy. We are dealing with an architecture that is 100% local, right?
Yeah, the documentation makes it incredibly clear that Datok operates entirely client-side.
Okay, meaning what exactly?
Well, when we talk about your typical ETL pipeline, so extracting raw files, running heavy transformations, loading them, all of that happens locally.
Wow.
Yeah, along with the data ingestion and the actual rendering of the visual charts. Every single operation happens locally in your machine's memory.
So where does the output actually go?
It's saved directly to your local hard drive.
The system architecture docs are very specific about this routing, right? Like it explicitly writes everything to a dedicated local directory.
Exactly. Specifically your C drive, under users, your specific username, documents, and then a dedicated Datok folder.
The implications for compliance there are just massive.
Oh, absolutely. Think about incredibly strict data governance frameworks like GDPR in Europe or HIPAA in healthcare.
Right. Normally, achieving compliance in a cloud environment requires endless audits, data processing agreements, complex encryption, key management. It's a nightmare.
But Datok inherently bypasses all of that. I mean, there is no middleman.
No third-party database administrator who could accidentally expose an S3 bucket to the public internet.
Exactly. Because the data never leaves the physical storage of your local device, absolute data confidentiality is just baked right into the foundation.
It's kind of like cooking in your own private kitchen.
I love that analogy.
Yeah, like the modern cloud model is the equivalent of packing up all your raw, unprepared ingredients, shipping them across the country to a massive industrial cloud kitchen.
And waiting in a huge queue for them to prep your meal.
Right, and then waiting for the finished dish to be shipped back to you. But Datok just gives you the industrial tools right on your own countertop.
And it also completely eliminates network latency.
Oh, sure.
Because when you aren't waiting for a remote server to query a database and send the payload back over Wi-Fi, the processing speed is dictated entirely by your own hardware.
So the time it takes to filter 1 million rows just comes down to your CPU strength?
Your CPU, your available RAM, and, the read-write speed of your local solid-state drive.
Which brings us to a really critical bottleneck. Because since everything is happening in this private kitchen, what happens when you try to cook a feast for 10,000 people?
Right, you hit the wall.
Yeah, we have to address hardware limits. Because we aren't spinning up infinite cloud compute clusters anymore, There is a physical reality to local processing.
There is.
Yeah.
We have to look at the environment where Datok actually runs. So the main interface operates inside a browser.
Even though it's local?
Yeah, even though it's processing files locally from your C drive, the application is still bound by the security and resource rules of the browser sandbox.
And browsers enforce strict memory limits,
Yeah.
right? Just to prevent any single tab from monopolizing your whole computer.
It's known as the JavaScript heap memory limit.
And the technical manuals give us the raw numbers on this.
They do, depending on if you're using Chrome, Edge, or Firefox. And depending on your OS, there's a hard limit.
It's between 1.5 gigabytes and 4 gigabytes of RAM allocated to that specific browser tab, right?
Yeah, roughly 4 gigs max.
But hold on, I have to challenge this logic. Let's say I'm a professional data engineer, right? I'm mapping out ETL pipelines on a high-end workstation with 64 gigabytes of physical RAM.
Good.
You're telling me the browser still chokes at 4 gigabytes? That seems like a massive flaw for a premium data tool.
I mean, if you try to load 50 million rows into a data frame in the browser, yeah, it will absolutely crash.
Just immediately.
Oh, yeah. If you exceed that JavaScript heap limit, the browser tab just throws an out-of-memory error.
Wow.
But we have to look at the architecture's fail-safe here. The physical Swilite databases that Datok saves to your disk, they are never corrupted when that memory crash happens.
Okay, so the memory fault is completely isolated to the interface layer.
Exactly. Your data is perfectly safe.
Right, the data is safe on the disk, but that doesn't really solve my problem. I still can't view or process my 50 million row dataset in the browser if it keeps hitting that 4 gigabyte ceiling.
Well, this is where you have to fundamentally change your workflow.
How so?
The tool essentially forces analysts to act like true data engineers. When you're building out your transformations in Datok's prep module, you aren't supposed to load the entire dataset into the UI at once.
Oh, you use downsampling tools.
Right. You apply a sample size limit, or you apply strict filters right at the ingestion point.
So you tell the engine, only load a randomized 1% of this data into my browser tab.
Exactly. You build a miniaturized version of your pipeline.
Okay, I get it. You use that 1% sample to test your joins, write your calculated columns, and just verify that your charts are rendering correctly.
All without ever coming close to the 4 gigabyte limit. You perfect the logic on the sample, and once it's airtight, you execute the full pipeline.
And the underlying engine processes the whole 50 million rows directly to the SQLite database on your disk.
Yep, completely bypassing the browser's visual interface limitations.
But what if I really need to bypass that browser limit entirely? Like, what if my workflow demands more local memory for the active session?
Well, Datok does have a solution for that if you're on a paid account.
Oh, they have a premium option for this.
Yeah, it's called Datok E14. Basically, it's a standalone desktop wrapper.
Like a datok.exe file.
Exactly. It's a custom browser tool, a dedicated wrapper that runs locally on your desktop.
And that gets around the JavaScript heap limits.
Yes, it completely bypasses those standard browser memory limits. So if you have that 64 gigabyte workstation, datok.exe lets you actually utilize that hardware to handle much larger data sets in real time.
Wow, okay. But just to be clear, most people are still using the standard browser version, right?
Oh, definitely. And we should emphasize that the main browser version is also 100% local, private, and secure. It never sends data to the cloud.
Right, so the datok.exe wrapper is just a premium release valve for power users.
Exactly. Most users will still use the browser version and just rely on smart downsampling.
Which honestly makes a lot of sense. It enforces discipline.
It really does.
Because for years, cloud data warehouses have allowed analysts to develop incredibly lazy habits. We just write a select query, pull massive amounts of unnecessary data, and let the infinite cloud compute sort it out.
And you rack up a huge cloud compute bill in the process.
Exactly.
Yeah.
Datok's limits whether you use the browser or the standalone wrapper. It shifts the mindset back to rigorous data engineering.
You have to actually understand the shape of your data. You design efficient transformations rather than just relying on brute force compute power.
Okay, so that makes total sense for the preparation phase. We've successfully processed our massive, highly sensitive data set locally. It's locked down securely on our C drive.
Right.
But the entire point of data analysis is communication, right? Eventually, you have to show your findings to a stakeholder.
Of course. An executive sponsor, an audit team, whoever.
But if this data is heavily locked down on a local hard drive and we refuse to upload it to a cloud server, how do we actually share the final dashboards?
Well, this is where their engineering really shines. Datok introduces a mechanism called the standalone report container.
Okay, what is that?
It's a single file. It has a .datok report extension.
I look at this file like freezing a fully interactive, living ecosystem inside a digital block of Amber.
That is a perfect way to describe it.
Right. You can hand this block of Amber to anyone, and the ecosystem inside still functions perfectly.
And the composition of that block of Amber is super fascinating. When you're ready to share, Datok packages everything into a single, encrypted-ready JSON container.
So what's actually inside it?
It takes the raw SQLite database that you just generated locally, aggressively compresses it, and then encodes it in base64.
Wait, base64 encoding turns binary data into standard text characters, right?
Yes, it does.
So they are literally embedding an entire compressed database inside a text file.
They are. And alongside that encoded database, the JSON container stores your dashboard layouts, the worksheets, the active filters, everything.
The metadata legends, the color formatting.
All of it is the entire analytical universe, totally self-contained within one file.
But if I email this .datok report file to a client, they're going to need a way to open it. And I don't want to force a client to buy a Datok license or install some heavy SQL client just to look at my bar charts.
No, nobody wants to do that.
And I definitely don't want to upload it to a cloud server to generate a sharing link because that defeats our entire local-first security model.
Well, Datok solved this by providing a free interactive viewer. It's essentially a static public web page.
Located at datok.eu/viewer.html.
Exactly. The stakeholder just navigates to that URL, and they simply drag and drop the .datok report file directly into their browser window.
Okay, let me deduce how this has to work, because this is a really critical security juncture.
Go for it.
If the recipient doesn't have a database client installed, and no data is being uploaded to a backend server, the browser itself must be doing the heavy lifting.
Right.
But standard JavaScript isn't built to query compressed databases efficiently. It would just freeze the entire browser window if it tried to parse that much data on the main thread.
Which is exactly why they leverage a technology called SQLite WebAssembly.
Commonly referred to as WASM, right?
Yeah, WASM. WebAssembly allows code written in high-performance languages like C or C++, which SQLite is built on, to be compiled into a binary format.
And that runs natively inside the web browser.
Yes, at near-native speeds.
So they're literally running a full-fledged SQL database engine inside the client's browser window.
Off-thread, yes. The SQLite WASM engine runs inside a web worker.
Okay, so it doesn't block the UI.
Right. When the stakeholder drops the file into the viewer, the web worker parses that base64 text, decompresses the database into the browser's temporary local memory, and handles all the queries in the background.
Without ever interrupting the main user interface thread. Exactly. So the client's own computer temporarily acts as the server to run the database. 0 database bytes and 0 dashboard metrics are ever transmitted over the network.
None. It guarantees absolute data confidentiality for the recipient, too.
And they don't need an account.
The recipient doesn't need a user account. They do not need a paid license. They don't have to install any software at all.
That's wild. So they can just interact with the global dashboard filters, hover over tooltips, and it just works.
Yeah, the SQLite WASM worker queries the data locally, updating the charts in milliseconds.
It's a 100% serverless, private sandbox. You get all the rich interactivity of a modern business intelligence platform with none of the cloud exposure risk.
It really is a masterclass in utilizing modern browser capabilities. I mean, they took WebAssembly and web workers and used them to solve a decades-old privacy problem in data sharing.
It's incredible. So we've established this beautifully isolated ecosystem. The data is saved locally on the C drive, pipelines are processed locally, and final reports are shared and viewed locally via WebAssembly.
Right. Everything about the data itself is walled off from the internet.
But then but there is a final piece to this architecture that honestly feels contradictory when you first read the manuals.
You're talking about the authentication requirement.
Yeah. Access to the actual Datok workspace tools, the software you use to build these pipelines in the first place, requires logging into a premium online account. Datok forces you to authenticate over the internet.
The application itself does require an active authentication ping to function, yes.
Why introduce a cloud vulnerability to a local tool? If my SQLite data is safely sitting in my local documents folder anyway, why is the online login security so critical?
Well, it's a good question.
Like, even if a hacker compromises my Datok account online, they can't magically reach through the internet and extract the files from my local hard drive, right?
No, they cannot. They can't access your local C drive just by hacking your online account credentials. The data remains physically secure.
Okay, So what's the risk?
What an attacker can do is hijack your premium subscription access.
Ah, so we are looking at a hybrid model here.
We are. If we look closely at the architecture, the local workspace interface, those proprietary ETL tools in the prep module, and the premium integrations like the datok.exe wrapper we talked about.
Yeah, the desktop app.
Yeah, and even running local AI large language models via Ollama to query your data, all of those features require an active subscription. The system constantly pings the server to verify your parental status.
Okay, so let's adjust our kitchen analogy from earlier.
Let's hear it.
Hacking the account isn't like stealing the kitchen, and it definitely isn't stealing the food inside it. It's like someone coming in and changing the locks on your kitchen door.
That is exactly what it is.
The food, your data is still perfectly safe inside, but you are completely locked out of the room. You have no way to get in, use your tools, process your pipelines, or generate those reports.
That's the exact vulnerability. You maintain data sovereignty, but you lose operational capacity.
Which is awful if you're on a deadline.
Right. And this is why Datok strongly emphasizes securing the account with Google Authenticator for two-factor authentication.
Yes, setting up 2FA is an absolute must here.
Definitely.
And for anyone listening who manages technical infrastructure, you already know the mechanics of 2FA. You generate the secret, scan the QR code, your phone generates the rotating 6-digit keys.
It's standard procedure.
Right. What's interesting here isn't the setup process, it's the strategic intent behind it.
The strategy is protecting intellectual property and operational continuity.
Because the data itself is entirely decentralized and local. It lives on edge devices.
But the software licensing and the access to the proprietary processing engine are centralized and highly secured.
It prevents a bad actor from guessing your password, taking over your subscription, and locking you out of your workflow.
Exactly. Even if they have your password, they are entirely blocked without physical access to your mobile device.
It's a vital moat around your workspace.
It is a very pragmatic approach to modern software design, honestly. You decouple the data storage from the application licensing.
You give the user total control and privacy over their sensitive information while maintaining a standard sauce security model for the software access itself.
Exactly. Best of both worlds.
Let's take a step back and synthesize the journey we've just been on.
We've covered a lot.
We really have. We started by exploring how Datok turns a standard local machine into a highly secure data fortress, aggressively pushing back against the default cloud computing narrative.
Then we examined the physical realities of the JavaScript heap memory limits.
Right, and we looked at how capping browser memory at 4 gigabytes isn't just a flaw, but a feature that forces analysts to become rigorous data engineers using smart downsampling.
While also offering that datok premium wrapper for the edge cases where you truly need to bypass those limits and use all your local RAM.
Exactly. Then we break down the mechanics of the standalone report container. We saw how packaging a compressed SQLite database into a base64 JSON file allows you to share massive dashboards.
And we explored how SQLite WebAssembly allows the recipient's browser to execute those queries off-thread.
Creating a completely serverless private viewing experience.
And we finished by unpacking the hybrid security model, understanding why securing a centralized software license with two-factor authentication is critical.
Critical to protecting your operational access to decentralized data.
Spot on.
So for you, the listener, this deep dive highlights a fundamental shift in what it means to be a data professional today. Being well-informed in this industry no longer just means knowing how to drag and drop variables to create a pretty chart.
No, not at all.
It means understanding the physical reality of the tools you are using. It means knowing exactly where your data lives at rest on your local disk.
Understanding how your system's RAM dictates your processing strategies.
Yes, and knowing how to architect a pipeline that maintains absolute privacy without sacrificing the dynamic interactivity that your stakeholders demand.
It is about taking total ownership of the entire analytical lifecycle, from ingestion to distribution.
Which leaves me with a final, slightly provocative thought for you to mull over as you look at your own workflows.
Oh, here we go.
For the last 10 years, the tech industry has been shouting from the rooftops that the cloud is the inevitable only way to handle heavy computing.
It's been the default answer for everything.
Right. But as our local edge devices get exponentially more powerful, as we see tools executing massive databases locally via WebAssembly, and even running AI models right on our desks, are we witnessing the beginning of the end for the centralized cloud era?
That is the big question.
Have we finally reached a tipping point where we realize we don't need to blindly toss our sensitive data out the window to a server farm when we have a perfectly capable, totally private kitchen right here at home?
I mean, the pendulum is definitely swinging back toward the edge. It's the question every single organization is going to have to confront very soon.
I couldn't agree more. Thanks for exploring this architecture with us. Until next time.